Welcome to Unit 11, where I'm going to step through the basic steps of the hands-on activity that is a tutorial available for you as part of this course. So the goal here is to introduce you to the setup and deployment of IPOP. You're actually going to run the code and you observe how IPOP works by running it on 2 virtual machines. And these could be deployed on many setups. It could be on your own desktop, it could be on a commercial cloud like Amazon EC2 or a academic cloud like FutureGrid. So you choose where you deploy them, and there are instructions on the website in this link that is shown here on how to set up the virtual machines on these different resources. And then you're going to install IPOP on these resources, and you're going to start it up, and you're going to see them getting virtual private addresses and see how they connect to each other. And in this example, IPOP nodes will connect through a public bootstrap overlay that runs as a service on the Planet Lab academic infrastructure. So the setup will then look as follows. You're going to deploy one virtual machine that we're going to call Alice, and it's going to obtain this static IP address in IPOP. You're going to define your own namespace for the IPOP virtual network, and you're also going to deploy a second virtual machine, Bob. And these 2 virtual machines will be able to ping each other, communicate with each other. And IPOP, the wide area overlay network that you're going to use as the P2P network where these machines are going to join, is this bootstrap overlay running on Planet Lab. And these are about 500 nodes. They come and go on a daily basis or even an hourly basis. But these are machines on the public internet that serve as IPOP routers for bootstrapping new virtual private networks. So the steps will be, you're going to deploy the Alice and Bob VMs. You're going to install an IPOP package, so that requires you to have the C# runtime mono in Linux, the IPOP binaries and configuration scripts and configuration files that have been set up to facilitate this tutorial. Then you're going to deploy IPOP nodes on these machines, observe that they connect, and you can later install and configure IPsec, so you can have end-to-end security, and then you can observe security at work by looking at the encrypted packets that are coming through the virtual network. Okay, so let me step through some of the basic steps of the tutorial to help you understand what's going on when you go through it on your own. So I'm logged in to a virtual machine on FutureGrid that's going to be used as my Bob virtual machine in the example here. I've already set up Alice, and I'm going to do the same process with Bob. So looking at the website for the tutorial instructions, the first thing we do is obtain configuration files for the tutorial. So this URL here. So this file is downloaded. We have to install unzip. The virtual machine usually doesn't come with unzip installed. That's a quick install. Here, unzip the configuration for the tutorial. And there's a script here that we're going to run, and this script basically sets up the machine with this tutorial. It's going to install IPOP and its dependencies, the C# runtime, and it's going to configure IPOP with a namespace, this IPOP node with a namespace and a static IP address. Now, the way to do this, you run this script and you give it a namespace. So we're going to say this namespace is IPOP MOOC1, and you give it a number for the last byte of the virtual IP address for this demo. And this is going to be my Bob machine, so I'm going to set it up with the last byte 20. So this starts the process of configuring the software that's needed to run IPOP. This will take a minute or 2 and installs mono and the IPOP binaries. So here, after the installation completes, the script that we just ran sets up this virtual machine to connect to this namespace and to use this IP address. And it sets up IPOP and starts the IPOP application on this virtual machine. So you can see IPOP running. It's this process here, user level router running under the mono C# runtime environment. And you can also look at the tap interface, which is the virtual network interface that this computer is connected. In fact, you can look at all the network interfaces of this computer, and you see that one of them, the Ethernet interface, is a private address, and it's one that's mapped to a public, in this case mapped dynamically to a public address because it's part of a private cloud infrastructure on FutureGrid. But here's the tap IPOP interface, and we're going to use this to try to connect to another machine that again is the Alice machine I have pre-configured before this example. So we're going to try and ping it by giving its address, Alice's address here. And what you see is a behavior here where, again, just like in the example of the grid appliance, you have a couple of packets that took a long time to do a round trip because they went through the Planet Lab nodes on the public overlay and multiple hops. So you see order of second delays here, but that just initiates the process of the connect to me messages and the setup of the net traversal with the other virtual machine. Now see that eventually we stabilize into a much smaller network delay, and this is because the two virtual machines that I'm running here happen to be in the same data center, in the same cluster. So these are less than a millisecond delay. What's important to observe here is that automatically the system was able to discover the endpoints for each node, and through the connect to me messages that were exchanged using the overlay, Alice and Bob discovered their endpoints. In this particular case, the endpoint will look like this IP address with a UDP port that's where IPOP is listening. So Bob, this machine, will tell Alice, this is one of the endpoints I'm listening to, 10.35.23.43, with UDP ports that it's listening on. And Alice will send the same information to Bob, and they'll both try to simultaneously create a connection to each other. And once that connection succeeds, IPOP creates an edge between Alice and Bob and starts moving the tunnel packets through that edge at a much better performance. So that shows the improvement, significant performance improvement that you get by having the adaptive shortcuts, as we saw on a previous unit. If you continue to use this, follow this tutorial, you're going to see how to install and configure IPsec on top of IPOP. I'm not going to show in this example. It's going to be left as an exercise for you to go through on your own.